Chapter 5.6b. So we're going to do the first question, letter A, fx equals 4x plus 3, and down below is the table for fx plus 3. So when you plug it -2 here, you got -5, and for the x value, when you plug it in here for x, you got y, or the fx is -1. Similarly, when you put 0, you got 3, and when you put 1, you got 7, 2, and you got 11. Gx is the inverse of the fx function, and the table below is, you can see that it's the same table that you have above, but in this case the x is switched as y and y is switched as x. So this was x here, it becomes y, so this is x and it becomes y here. This is y and it becomes x. So remember, when you solve the problem in 5.6, you were solving the problems by switching x and y. So let me remind you, you have here is fx equals 4x plus 3. You set that equals to y, and then you switch x and y. So you switch x and y, you got x equals 4y plus 3. And then you solve for y. When you solve for y, you subtract 3 on both sides. When you subtract 3 on both sides, what you got here is x minus 3 equals 4y, and you divide with 4. You got y equals x minus 3 over 4, and that is your gx, which is your inverse of the function fx. So this is your gx, which is this function right here, and this is your fx, this is this function over here. How you got from fx to gx? By switching x and y. Similarly, in this case as well, you notice that this x becomes y and this y becomes x in inverse. So this is the relationship between the function fx and its inverse, which basically is switching x to y and y to x. So now let's compare this graph given here with these functions here. So 4x plus 3, which means that this has a y-intercept as 3. So if you use this equation, the graph you're going to get from this equation is this graph right here. So this graph right here. So you can compare it if this is actually the graph for this function or not. So first point is -2, -5. So -2, -5 is this point right here, -2, -5. And the next one is -1, 1, which is this point, which is a cutting point for both the lines. This point right here, you can see that this is a y-intercept, or is this point 0, 3, and then the next one is 1, 7, which is this point, and the other one, the last point, is not on the picture, but it's 2, 11. So we got that this is the graph of the function that was given originally 4x plus 3. Now this is gx, which is this one right here. If you turn the gx into gx equals 1 over x minus 3, and then you compare this one with the mx plus b. So these points, the points that are -5, -2 is right here, -5, -2. The next one is 1, -1, is right here, where the two graphs are intersecting, and the next point is 0, 3, 0, and then this point is 7, 1. So we got that this line is the graph for gx, and this line is the graph for fx. What do you notice about the graph? You can see that this graph are the reflection over the y-x line. The green line that you see is the yx line, y equals x line, where it starts from the center or 0 0 and it's go up 1 over 1, up 1 over 1. That's why it's called y equals line. So this graph is, these two functions are reflected on this line, y is equal x. So what do you notice about this graph? That the x and y points are switched. X and y are switched and they're reflected over the y-axis line. For letter B, you have, this is x squared. It's a square function. It means it's a parabola. You're going to look at the same way you analyzed this graph and the points. You can see that these points for this one is 0 0 1 1 2 4 and 3 9. The inverse of x squared is square root x. We did this question in the past lesson. Switch x and y and solve for y. Same thing. Now, if you notice the points for x, same thing. You have y, x becomes y, and y becomes x. If you notice that the points for the fx equals x squared, you can see that these are the points for x squared, which is starting from 0 0, so 0 0, and then the next one is 1 1, and 1 1 is a common point for both the parabolas because they are, one is parabola and one is a square root function. So this is a square root function and this is a square function. Next point is 2 comma 4, which is this point 2 comma 4, and then the last one is 3 comma 9. For the other graph, that is square root function, for the square root function you have a point that is 0 0, which is this point. It cannot have a negative, so that's why we leave the negatives. Next point is 1 comma 1, which is a common point for both the functions. Next is 4 comma 2 and 9 comma 3. This function, the inverse functions are reflected over the y-x line. Y equals x is this line. What do you notice about this line is again the same thing, that the x and y are switched. X and y are switched and they are reflected over the y equals x line. For example, finding the inverse of a linear function and graph the function and its inverse. So first of all, we want to find the inverse of this function. You're going to set fx equals y. So fx equals y, so y equals x plus 5 divided by 2. Now you're going to switch x and y, so you're going to switch x and y. What you got here is x equals y plus 5 over 2. Now you're going to solve for y, so you're going to multiply 2 on both sides. 2 and 2 cancel, so you got here is 2x equals y plus 5. Subtract 5 on both sides, y equals 2x minus 5. And this is called gx, which is the inverse of the given function fx. Now we are going to graph both of the function on the graph here. So first we are going to graph the fx. To graph fx, you're going to turn that into 1 over 2x plus 5, where 5 is going to be your y-intercept, so which is this point, 1 2 3 4 5, this point right here, up 1 over 2, up 1 over 2 on the other side 2, or down 1 over 2. You just follow the pattern. That is going to be a rising line from left to right because the slope is positive. To graph another line, and that line is the inverse function 2x minus 5, where you have negative 5 as your y-intercept. The slope is 2, so here is the slope. So you're going to go up to over 1, up to over 1, up to over 1, and up to over 1. So when you combine these points, you're going to get a line graph for the inverse function. So the question was that you're going to find the inverse of this function, which we did, and then you graph the function that was given function and its inverse. So same thing for the next question. You are given with fx equals 1 over 3x minus 1. You're going to set the y for fx, and then you're going to switch x and y. So when you switch x and y, you got x equals 1 over 3y minus 1 plus 1 on both sides. You got x plus 1 equals 1 over 3y. You're going to remove the 3, so you're going to multiply 3 on both sides. So 3 and 3 cancel. You got here is 3x plus 3. So you're going to distribute this 3 with both of them, and that is equals y or gx. Just remember the final answer you got as y is going to be your inverse function. So this is going to be an inverse function, and this is a given function. Now you're going to graph both of them. So you're going to graph the fx. Now for the fx function, you have a negative 1 as your y-intercept. Slope is up 1 over 3, up 1 over 3. You can extend it on the other side. For inverse function, you start from 3 and you have a slope 3 over 1. So you start from here, that is 3, and you're going to go up 3 over 1, up 3 over 1. You extend the line on both sides, up 3 over 1, and you connect that, and you're going to get a line graph. For number 1, you have a fx equals 1 over 5x minus 1. You switch the fx as y and then switch x and y. You solve for y and you got y equals 5x plus 5. Now you're going to graph both of the function, the original and the inverse function. For original function, you have a negative 1 as your y-intercept, up 1 over 5. Up 1 over 5 is this line. For the inverse function, you have 5 as your y-intercept. It's going to be up 5 over 1, or on the other side is going to be 1, 2, 3, 4, 5 over 1, 1, 2, 3, 4, 5 over 1. So they intersect at this point where y equals fx is the line of reflection. For number 2, this is y equals 1 over 2x plus 2. You're going to switch for x and y, and x becomes 1 over 2 y plus 2. Subtract 2 on both sides. You got x minus 2, 1 over 2 y. You're going to multiply 2 both sides. You got here 2x minus 4. 2 and 2 cancel. That is y, also called gx, and that's your inverse. So to graph the fx, you have a 2 as your y-intercept, and you have 1 up over 2, 1 up over 2, and extend the line 1 down over 2, 1 down over 2. For the inverse function, you have negative 4, up 2 over 1, up 2 over 1, up 2 over 1, and they intersect at this point where the y equals fx is your line of reflection. that is y equals x.